Hi, my name is Toby Whitson. I have a case study about an interesting topic called CRISPR. That's the abbreviation for it. What it actually means is clustered. It's a clustered regulatory interspaced short palindromic repeats. It is basically a mechanism which edits genes or DNA within your body. And this is something that's highly beneficial. Way more beneficial than it's known for. Of course, there is some problems with it, but there is the creator of it. His name was Hiroshima, and he worked at a university. And at this university, what they did is they was working on to find a way to splice genes. Ultimately, they stumbled upon it accidentally. As most prominent scientists do, they was running tests and whatnot and found that some enzymes could capture DNA from organisms and snip that DNA out. It is something very, I guess you would say minimally researched, but it has drastic impacts to help the future generations. See, these enzymes take out DNA, certain snippets of DNA, and then can replace it with other snippets of DNA. And of course, there's a multitude of ways to do this. There's bacteria, enzymes, and a few other processes which aren't mentioned because they're not used enough. So, what I find interesting though is they use Cas9. It's a type of enzyme that's used the most. What this enzyme does is, like I said, it snips out the DNA, but it can snip out very specific parts of DNA. What makes that so great is there's some things in people's DNA that can cause cancer, and it's not even needed. So what this enzyme can do is it can go in that DNA, snip it out, and replace it with a good gene. So that basically cures cancer before it happens. Of course, this is a rudimentary practice since it's not looked into much and it needs a lot more research done into it. But it is being used today, although I would like to say that it's not at its top of the line use. It's basically like when we first discovered electricity. We knew that it had a ton of potential, but at the same time we couldn't utilize that potential. With CRISPR, that's how it is. We know it has a ton of potential, and we're using it a little bit, but not to its full potential. And see, now I'll get to the benefits of it. Not only can it cure cancer, but it can cure problems in the womb, in a fetus, before it ever even contracts those diseases. Now, what this does is, as I was saying, it takes snippets of DNA. So in a fetus, it can take the snippets of DNA, take those out, put new ones in, and completely fix the disease before it came. So theoretically, this could be used to fix things like autism, a lot of birth defects, and then, most of all, a lot of blood diseases that can't be cured after they're contracted. Like a lot of this types of cancer, like blood cancer, for example, leukemia. Now, the only bad parts to this is there is a small chance that when certain DNA is taken out, it can lead to cancer. Now, there's more studies going into this, but right now it's hard to say. With CRISPR, like I said, it's not that looked into of a topic. They're using it a lot, but it needs more work into it. So, there is problems. It can cause cancer in minimal cases. When it does that, it usually comes from a user error instead of the machine itself. But, like I said, still needs some research into it. Overall, though, it is perfect. It's basically going to be a future innovation, which will lead medical practices as we know it. And so, it's something so interesting to look into. I was so fortunate to do a research topic on something like this, a case study, because this thing is endless. There's not much that it can't do. Now, another bad thing about it is it uses stem cells. And most of us know where stem cells are derived from. So that becomes a moral issue since it comes from aborted fetuses or other means of extraction of stem cells. Sometimes that involves the umbilical cord, things like that, but that's not always the most suitable way. Usually the best way to harvest it is from aborted fetuses, and that's quite sad to say, but they haven't really looked in. I'd say they've looked into it, but it's something that without prominent research and due to ethics and science, which isn't a bad thing, it's not necessarily been experimented with to see if there's other means of extracting stem cells, because they deem it not worth the risk of experimenting with fetuses. And of course it's not worth the risk, but it just needs research into it to extract those stem cells, in short. So that's the main dilemma here, is finding stem cells that you can get the DNA from in order to put that in DNA. But all in all, it is a very prominent topic, something so interesting to do, and like I said, it can lead the way for medical scientists, as we know, and it's just an all-around great thing. Thank you for listening.